Yeah. There are 10 presentations in this session. Let's start with the first presentation. First presentation, dear Fatma Mansur. Not online. Dear Walid Saleh.
Yes, Doctor. I am ready to
Okay, you
presentation
can start.
my paper. Yes, Doctor. Can I share my screen?
Yeah.
You see it, Doctor?
Yeah, no problem.
Yes. Yes. My name is Walid Hamid Saleh. Title my paper, A Deep Learning Approach to Differentiate Between Acute Asthma and Bronchitis in Preschool Children. Outline, introduction, methodology, results, and conclusion. Introduction. Acute asthma and bronchitis are common disease that infects the lower respiratory disease of children around the world. These diseases can be caused by a viral or bacterial infections. It is considered a major reason for increase in the number of deaths among children as result the rapid spread infection, especially in low and middle income countries. These diseases can occur at any age, but they often start in preschool children, such as under 6 years. And there are overlap symptoms between two diseases which cause and make it difficult to differentiate between them, as cough and shortness of breath and wheeze and runny nose, etc. The physician often look for other unsimilar symptoms for each case in order to accurate diagnosis to differentiate between two diseases. Deep learning have gained great and noticeable interest in the field of healthcare worldwide through reduced pressure on healthcare institutions in many countries, especially those with the limited income that lack medical equipment and devices, and in event of a shortage of medical staff. In this study, we will use two models of deep learning, convolutional neural network and long short-term memory, and compare between them to get the high performance. The aims reduce time and effort and money, and helping the junior doctor in the hospital by making the correct and accurate diagnosis. The methodology. The general framework of the approach will be built as the figure, which includes building two models for a data set of 512 real data set cases with the 12 attributes for each case that were examined by pediatric consultant inside the hospital. After then, the pre-processing of dataset. Pre-processing of dataset includes data profiling and data cleaning and data reduction and data conversion and data enrichment, with the split data into 70% train and 30% test. And we use the certified cross-validation use ensure equal and homogeneous distribution of subgroup during training data. The main objective of the data stratification is to reduce sampling error in order improve the representation of sample accuracy. One, the convolutional neural network model. We introduced the first model of one-dimension convolutional neural network for binary classification that fit with our data set. Our data set is text numerical. My data set is numerical. We have applied organization techniques to avoid overfitting during training and testing, where the input data is represented by a one-dimensional array. We built the model with the 3 sequential convolutional layer with the filter 32 and 64 and 128. We used 3 kernel size for each convolutional layer to extract the feature from one-dimensional array that was multiplied in the input improve the output in a desirable way, as the filter improve in only direction, so that output is the one dimension. We use dropout after the layer different proportion 0.1 and 0.2 and 0.3 after each convolutional layer, according the size of the convolutional layer, to avoid overfitting during training the data, and effect so that if the not present is the effect layering in the appropriation way. We also use max pooling layer of size 2 to extract features and reduce the construct. So reduce the size of the data, the number of parameters, by taking the largest value to keep it the pooling rectangle. We have added fully connected input layer, flatten, turn the output, the previous layer, into a single vector that can be input to the next stage. Also, we added the first connected layer with the filter 100 to 8 and dropout 0.3 to apply weight to predict, and the fully connected output layer the sigmoid function value to give us the result 0 or 1 as rectified linear function ReLU was also used the convolutional layer because it is easy to calculate and only involves comparing to the value 0. The long short-term memory models, LSTM. We proposed the model with the size our numerical data, and we initially create LSTM layer with the 100 memory units smart neurons, and we added to the return sequence with the return hidden state output to each input time step. And the second LSTM also had 100 memory models with the refer ReLU functions, and after each layer we use the dropouts at 0.2 percentage to reduce overfitting. We distributed fully connected layer sequential after LSTM layer dropout each layer for them avoid overfitting, and since our problem binary classification, we use sigmoid activation function to get the classification of either 1 or 0, because my problem is the binary classification. The result of CNN, we use 3 convolutional neural network, one dimensional. The first convolutional 32, and the second 64, and the third 128 with the kernel size 3, and the activation function ReLU with the dropout arrangement 0.1, 0.2, and 0.5, and fully connected 100 to 8 with the ReLU and with the dropout 0.3. The final fully connected sigmoid, because my problem is the binary classification, the output either 0 or 1, and this is 0. Sorry, this is the epoch for accuracy curve and loss curve. This accuracy curve and loss curve. Final LSTM, also LSTM. We use LSTM 2-layer memory unit, 100, 100, and fully connected 100 to 8, and 64 and 38 with the ReLU, and the final fully connected sigmoid. Also, we have problems binary classification 0 or 1, and this is accuracy curve and loss curve. Final comparing between convolutional neural network and LSTM. Details. Test accuracy 99.35 and LSTM 98.70. Test loss 0.43 and 0.48. Time in CNN 60 millisecond and LSTM 46 millisecond. Also we use area under curve. Area under curve in CNN 99.32 and LSTM 99.86. Epoch 50/50 to CNN and LSTM. Total parameters with the convolutional neural network 80,000.4099 and with the LSTM 144,000.497 because LSTM feedback to the neurons. The parameter in LSTM greater than convolutional neural network. Optimizer, we use optimizer Adam to the convolutional neural network and LSTM, and batch size 64 and 64 to the each CNN and LSTM. Conclusion. Deep learning algorithm were applied to our real data set of 512 prospective cases that were collected with the consultant doctor within 4 months from March month 2022 until the June month 2022. And since our data is the textual numerical to working model have been proposed are one-dimensional CNN and one-dimensional LSTM. One-dimensional CNN achieved a high accuracy of 99.350 over its counterpart with the achieved rate 98.7001. The one-dimensional CNN model was choosing this study to differentiate between acute asthma and bronchitis in preschool children. This model will provide many advantages, including reducing time, effort, and money for junior doctor and health staff in hospitals, especially in countries with the limited income. Thank you for your listening.
Thank you for presentation. Is there any question?
Yes, I'm ready. If you have any question, I'm ready.
Okay. Okay, next presentation. Here, Fatma Mansour. Can you stop share? Dear what?
Yes, Doctor, I will go out from the share screen.
Yeah.
Yes, Doctor.
Next presentation, dear Melikcan Topal.
Can you see my screen?
Yeah, you can start.
Can you see my screen?
Yeah, no problem.
Hello, everyone. My name is Melikcan Topal. I'm an electrical engineering student at Istanbul Technical University. And I will present our study training an open quantum classifier. Firstly, I want to introduce an open quantum system and collisional model. And I would like to report the analytical result of the operating principle of the quantum classifier. And then I will show the results of the training simulation. We describe a quantum information reservoir composed of identical and non-correlated qubits in accordance with the collision model. The general representation of quantum state can be written is like this, is psi state. And we take our study, we take phi is 0 fixed and denote the amplitude parameter by theta. The system, it means probe qubit, our probe qubit plus reservoir state is initially assumed to be in a product state, with our system qubit and the reservoir. We choose initial system state as plus state to provide null magnetization. Here the open quantum system model and the unitary propagator define each collision between the probe qubit and each reservoir qubit. And the total Hamiltonian of the system describes the during the interaction between the probe qubit and the ancilla. And here the visualization of quantum collision model. On the middle, the probe qubit, our probe qubit, and the information reservoirs are located on the top and the bottom. Here, I was said total Hamiltonian described like this, and the free term is in the equation, and in the resonant case, which our frequency of our probe qubit and the frequency of reservoir are equal, and the Hamiltonian of interaction described like this after we choose the resonant case. And here G sub I is a coupling string, and it's an important for us to build a classifier. The system evolves into a state that's similar of the ancilla, which is the reservoir in our system, after a sufficient number of collision, in which we have called quantum homogenization, since our proposed model is a Markovian model. And the system reaches a steady state as like phi state, and it's a partial trace operator since we use open quantum system. In order to get a steady state, the system steady state, we have to use a partial trace operator, and here n tau is the time for an n collision. After the process of collision model, the readout solution of the probe qubit is like this as a density matrix. And now we can build a classifier. We choose a steady state magnetization as a merit quantifier for a binary classification decision. As you can see here, we consider a coupling string, Gi, as a weight of the classical perceptron. And there's a functional proximity between the classification rule and the classical perceptron. As we can see in the figure, since we have two information reservoirs, altering couplings leads to a variation of the steady state magnetization. And cost function. Using least squares method, we can define a cost function as a like this, and here y is an output and a is an input, and we can define a cost function like this. And in our system, cost function defined as like this in the equation. Now we have to minimize the cost function. Well-known way to minimize the cost function is gradient descent method. And as you know, we take partial derivative of the cost function with respect to coupling strengths, express the variation of coupling rates in the direction of greatest descent. And learning rate, behavior of the decreasing on the cost function changes with the differing learning rates. As you know, learning and as you know, learning rate is the how big learning steps will be, and using low learning rates leads to smooth changes in the cost function. In our case, we have two information reservoirs. Therefore, the actual state magnetization read as in the equation. And here on the right, in the figure, the dashed line in the figure describes the decrease of the cost function corresponding to successful updates of G sub I and G sub 2 parameters. In conclusion, we can see there is a possibility of the trainability of an open quantum neuron model. And since the classification decision of the model is obtained in the steady state, which means there is no additional optimization algorithm is required as in the quantum computing circuit model. And in the end of the presentation, I would like to thank TÜBİTAK and Cognitive System Laboratory for their contribution. Thank you for listening. And is there any question? I'll be happy to answer them.
Thank you for presentation.
One question, please.
Yes.
Yes. Did you meaning you develop the classifier like SVM to classify any type of data for only binary or multi-class?
Only for binary classification.
Mm-hmm. So it's like SVM, classify classes, but SVM can classify different types of classes, right?
Yes, yes, yes.
Mm-hmm. Thank you very much.
Is there any question? Thanks again. Next presentation. Dear Alihan Su İçmez. Alihan Su İçmez.
Hello, Doctor. I am
My
ready.
screen, can I screen my share?
Okay, you can start.
Okay. In this presentation, I will talk about the evaluation of AOG signals with the help of machine learning with feature selection methods. 1 minute. The name of work is comparison of different feature selection methods using support vector machine for estimating IANGs. The content of presentation consists of the following steps, respectively, the aim of study, the dataset use, equation of feature extraction method, the artificial intelligence model use, and finally, result of the study. people become disabled as a result of deformation in different organs or system as a result of various accidents. The accumulator system is not affected by these disorders. Human-computer interface system are used to reduce these problems. The electroencephalography is a low-cost recording technique that can record electrical activity produced by the eye. Technology products enable the transmission of human gaze as input to computer system are on the rise today. Example of techniques for tracking, evaluating, and even predicting people's gaze are quite common in literature. This study performed feature extraction of electroencephalography signals separately in horizontal and vertical channel. Then with 5 different selection methods, the features that might have a high impact on estimation were determined. Afterward, the results given as input to machine learning algorithm support vector regression were compared in the RMSE metric. The AOG data used in the study will provide the Barbara et al. Taken from. The format of the dataset used is in .mat format and consists of 3 components. The first is AOG.mat and includes the horizontal and vertical components of sign. Second, control signal.mat contains a control signal of the same size as AOG.mat. The last one is target angles.mat, which consists of absolute perspectives. The baseline drift in dataset is eliminated by using a high-pass filter with a cutoff frequency of 0.03 Hertz. Figure 1 shows the raw and filter horizontal and vertical AOG channels. The control signal.mat signal matches the angular values corresponding to the AOG signal. The feature extraction was done using the features in the table. This table lists names and equation of the feature. In the same way, the features and equation continue in this section. In total, 23 features were used. This study examined 5 feature selection methods used in MATLAB environment, namely unvariative feature ranking for regression, neighbor component analysis, minimum redundance, maximum relevance, RLFF, and sequential word. In MATLAB environment, FCR test using F-test, it usually ranks the most important features that will reduce the error rate for the regression. Algorithm in the order of importance. Figure 2 shows the order of importance of the features for vertical and horizontal channel, respectively in A and B. 15 features were selected in the vertical channel and 16 in the horizontal channel. NCA measures the regression loss of the data given to the training that learns the features weights to minimize the loss, and NCA makes feature selection. Figures 3 A and B show the distribution of features according to their weights for the vertical and horizontal channel. 11 features were selected in vertical channel and 8 features in horizontal channel. Usually, for regression, minimum redundance reveals the maximum relevance, returns a function containing in indexes of estimators, short by importance of estimator. Figure 4 shows the order of importance of the features for the vertical and horizontal channel in A and B, respectively. 15 features were selected in vertical channel and 16 in the horizontal channel. The RLFF method performs the order of importance of estimators. The sorting process works on the principle of penalizing estimators that given different values to neighbor with similar response values, while rewarding estimators with different values. Figure 5, A and B show the order of the features according to the importance weight for the vertical and horizontal channel, respectively. 18 features were selected in vertical channel and 6 features in the horizontal channel. In the sequential forward selection method, no feature is selected at the beginning. When a feature is found that will improve the result in the best way, is add The addition process is done sequentially and continuous with the addition of candidate feature that contributes the most to the development. This process is terminated when the evaluation result is optimized and desired number feature is reached. 6 features are selected in vertical channel and 5 in the horizontal channel. Artificial intelligence model, SVR, is a version of SVM for regression that works well in many data mining and signal processing applications. Estimation of angular eye displacement was made using K-fold method for SVR and KAQS5 in the MATLAB environment. Result of study and a comparison of errors according to select features using feature selection methods is given in table 2. Looking at RMSE values in table 2, the FCR-MR feature selection method with the SVR machine learning algorithm show the best result, both the vertical and horizontal channel. In this study, new feature selection methods and SVR regression model were used to estimate different eye angles using AOG signal, and high performance was achieved. Dear participant, thank you for listening to me.
Thank you for presentation. Is there any question? Okay, next presentation. Dear Saleh,
Yes, Doctor.
you can start.
Yes. Hello, Doctor. You hear me? Hello.
Hello.
You hear me? You hear me, Doctor?
Yes, we can hear you.
Yes, yeah.
Yeah.
Yes,
You can
Mustafa,
start.
continue. Yes.
Yeah,
Okay.
continue.
The title of my presentation, Diagnosis of Respiratory Disease for Children Using Machine Learning, prepared by Mufid Saleh. Outline, introduction, proposed approach and method, result, and conclusion. The introduction. Respiratory diseases are among the common diseases that affect children around the world. And it is a devastating cause for global health because it is considered a major reason for the increase the number of deaths due to the rapid spread of infection in children. The most common respiratory diseases that affect children at an early age, some of which are chronic, and some respond to treatment for a while. And they are bronchiolitis, pneumonia, and asthma, which are characterized by similar symptoms, especially in children below 2 years. These 3 diseases share similar main symptoms, such as coughing and wheezing, in addition to other symptoms, such as temperature and difficulty feeding. The inexperience of junior doctor in primary clinics, as well as children under 2 years, who cannot express the pain in understandable and clear manner, which is based on complaints lodged by parents, is a big problem in pediatrics that leads to difficulty in accurate of diagnosis and respiratory disease. Actual diagnosis these types of disease and differentiating them based on clinical symptoms is not easy, especially for junior doctors, which may inaccurate diagnosis and thus endanger the lives of children. The orientation and work will be to find alternative solutions that are available and that are not financially costly. The word orientation is to use and introduce modern technology in medicine, which is a short way to finding a quick and accurate solution at the lowest financial cost. In recent years, machine learning methods have gained great interest to detecting respiratory disease by using accurate algorithm and models. Proposed approach and method. The structure of the proposed approach. The pediatrician at Fallujah Hospital for Women and Children, who is a consultant specialized in pediatrics and the scientific agent for the hospital director, was contacted. It was agreed to work together to help me complete the practical side of the healthcare. Actually, the work began on 1 of December 2021 to collect data set, a real data set from the sick children. The method of collecting data varied by receiving patients between emergency rooms and pediatrics consult. At first, it was agreed with the consult doctor to determine the special features of each respiratory disease. 7 general attributes were taken from these diseases, as in this table. This table represents the attributes which temperature, runny nose, cough, feeding difficulty, on auscultation, family history of atopy, and smoking in the family. In the case of bronchiolitis, the temperature must be low-grade fever, 38 to 39 degrees, and runny nose positive, cough positive or negative, feeding difficulty positive, on auscultation, with without crackles. Family history of atopy positive or negative, smoking in the family positive or negative. In the case of pneumonia, the temperature must be more than 39 degrees, runny nose positive or negative, cough positive, feeding difficulty positive, on auscultation, focal crackers. Family history of atopy negative, smoking in the family positive or negative. In the case of asthma, the temperature must be normal or less than 38 degrees. Runny nose positive or negative, cough positive or negative, feeding difficulty positive or negative, and on auscultation resistant with family history of atopy positive and smoking in the family positive. When description of the data set during the period between 1 December 2021 and 1 March 2022, a questionnaire was made with the clinical diagnosis according to this table, which or previous table, which was developed in a coordination with the pediatrician to work in Fallujah Hospital for Women and Children, where the real data set was taken for 344 children under 2 years were suffering from respiratory disease distributed over 123. One child was suffering from asthma. 142 had bronchiolitis and 79 had pneumonia. It was sufficient to take this number of patients due to the beginning and end of winter during this period within the study area. This figure represents the framework building and choose our modules. The data set taken from hospital and make it the pre-processing and cleaning it. By using this method, we split the data set to train and test data by using tenfold cross validation. Then build our model by using the algorithm or machine learning algorithm, which is logistic regression and naive Bayes. And by using the evaluation and error matrices, test this model and get the best model. The result will be presented for each classifier using evaluation and error matrices, and for comparison between 3 diseases of the respiratory disease for children, namely asthma, bronchiolitis, and pneumonia, with the presentation of the weighted average. This table represents the differentiate between three diseases, which is asthma, bronchiolitis, and pneumonia, by using logistic regression algorithm. The average of all evaluation matrices was 99.1, and using the error matrices rate, the result of mean absolute error was 0.0058, and root mean squared error was 0.0732. And this table represents the differentiate between respiratory disease by using NIPE Bayes classifier. The weighted average for all evaluation matrices was 99.7, and the error matrices rate, the result of mean absolute error was 0.0027, and root mean squared was 0.0452. Finally, after comparing the result of two models in terms of evaluation matrices and errors, a comparison will be made between two models using the accuracy criterion. Based on that, our model is selected. The table below shows the distinction of the NIPE Bayes model with an accuracy rate of 99.7093 over the other model to be chosen a reliable model in the future classification of these diseases. Conclusion. It was not easy to obtain many real data of respiratory disease for children under 2 years of age during the peak period for a separate of this disease, which was limited period, 3 months during to the winter season. And the use of the tenfold cross-validation method was an important rule in increasing the accuracy rate due to the adjustment of hyperparameters, simply the data into the original training data, and saving the test data in the form of the invisible data until the model is selected. Actually, in the future work, we recommend that there an unlimited period to collect the largest number of samples from the real data set to that we can use additional algorithm and translate our work to creating a smart application on mobile devices to help the junior doctors improve faster diagnosis and differentiate between respiratory disease for children. Thank you for listening, Victor.
Thank you for presentation. Is there any question?
Yes, I have a question.
Okay.
Did you use a PCA method?
No PCA method.
Hmm.
Just
I have a
a
question.
tenfold cross-validation method in machine learning.
I have a question.
Yeah.
How can you be sure your result is the better result if the data is open access? It must be comparison with other people. They use the same data. Is that right?
The same data. When I comparison, the NIPE Bayes get the result more than of the logistic regression. The logistic regression,
I mean
99.1.
the other study. Wait. I'm meaning the other study. Maybe someone used the same data and achieved a higher result.
Yeah.
So how can we be sure your result is better than others?
Yeah. The previous studies, all previous studies use 1 or 2 diseases. I'm used 3 diseases.
No, I'm meaning the data is open. This is the question. And how can you be sure if you don't compare it and shown in the table? It must be there a table.
In the previous studies, they don't use this disease, and I sure by using our models.
Okay. Thank you.
Thank you for it. Any question, Victor?
Okay, no question. Next presentation. Dear Fatma.
Merhaba, my name is Fatma Mansour. My paper title, A New Framework for Defect Detection Using Hybrid Machine Learning Technique. Can I share my... Yes,
You can share on screen.
please, Annie. You can see my screen now.
Yeah, no problem. You can start.
New framework for defect detection using hybrid machine learning technique. Smart cities, introduction of smart cities is a technologically modern urban area that uses different types of electronic methods, voice activation methods, and sensors to collect specific data. Information gained from that data is used to manage assets, resources, and resurfaces efficiently. In return, that data is used to improve operation across the city. This includes data collected from citizens, devices, buildings, and assets that is processed and analyzed to monitor and manage traffic and transportation systems, power plants, utilities, water supply networks, waste, crime detection, information systems, schools, libraries, hospitals, and other community services. Smart cities are defined as smart both in the ways in which their governments harness technology as well as in how they monitor, analyze, plan, and govern the city. The aim of this study is developing new method based ICA and SVM based grid search for defect detection in commune network system. This study presents new method to prevent defect detection in commune network system. A proposed method, the usage of wireless technologies in computer systems renders it vulnerable to cybersecurity threats. With the increase in data volume, it's now possible to employ machine learning for detection and prevention of anomalous behavior, intrusion, cyber attacks, and malicious activities, as well as data authentication. Defect detection in commune network system is a system that monitors network traffic for suspicious activity or generates a warning when such activity is detected. A software application that check a network or system for malicious activity or policy violation. In this study, ICA-based SVM proposed for defect detection in commune network system. The ICA reduced the size of input features to reduce the computation rates. In the second stage, the output of the ICA were to the SVM. The SVM classify the features to three attacks or not, normal and abnormal. The proposed system presented a result which 99.1% accuracy with when compared with several studies. The grid search used to find best combination of SVM parameters to obtain best result. The experimental results show that our method presented high accuracy. Three techniques used to classify the IDS data, decision tree, DT, linear regression, LR, artificial neural network, MB, and regression RAM plus K support vector machine, which produce 80 85.56, 83.15, 82.07, 81.34, and 93.52 respectively. The other apply a rapid approach based on a genetic algorithm. The 47 features are become input to these classifiers, and the output accuracy are calculated and listed in the table. SVM are applied to detect IDS attack and produce only 83.16. Then our method presented remarkable result when compared with a previous study, 99%. Conclude, the new proposed method consists of ICA, SVM, a grid search. The grid search used to obtain best parameters of SVM, which reduce the computation time and increase the accuracy performance. The model has ability to classify difficult problems and produce satisfactory results when compared with presented result in survey studies. Future work, the proposed framework can be used in various other fields such as community network security, speech recognition, and video classification. Furthermore, the framework can be developed by using algorithms to optimize the performance of SVM or effective features extraction techniques instead of mere waves. Thank you for your listening.
Thank you for presentation.
Thank
Is
you.
there any question? Okay, thanks again. Next presentation, dear Fulya Akdeniz. Dear Akdeniz.
Can you hear me?
Yeah.
Sorry. 1 minute. Now, can you hear me?
Yeah. Can you share on screen?
Can you hear me?
Yeah.
Oh, sorry. I will start my presentation.
Okay.
Dear all, thank you for joining my presentation for 6th International Symposium on Multidisciplinary Studies and Innovative Technologies. Before starting to my presentation, I would like to introduce myself. My name is Fulya Akdeniz. I am a PhD student at Kocaeli University Department of Computer Engineering. I will go over the topic that you see on the screen right now. First of all, I start content of study, why I choose the study. Then I mention about digital audio data and audio forensic, audio tampering. Then I mention related works. Next, I will talk about material and methods. Then I discuss my paper and last one, is conclusion part. Motivation, as you know, digital multimedia is known as one of the most important research area currently. Audio, image, animation, and video factors are most important source of digital multimedia. People who don't have professional training in the field of audio, image, and video can easily make changes to audio, image, or video files by way of smartphone, smart device, and various web application. Any changes made only cause break the integrity, authenticity, and
Sorry,
security.
sorry.
Yes.
Can you continue the slide?
Sorry.
Can you continue the slide?
Yes. Can. Sorry.
First slide. Yeah. Okay.
1 minute. Can you see now?
Yeah.
Motivation slide.
Yeah.
Okay, sorry. Proving the accuracy and authenticity of audio records is of a crucial issue in forensic science. Importance of digital audio data. The digital audio data is important because currently in the authentication system, digital audio recordings are used instead of analog audio records for security systems. When there are any operation on digital audio records, emerge trace are almost impossible to detect. Visual and audio trace that will occur on audio recording analysis and detection is challenging. Hence, detection forgery operation on digital audio records is open-ended problem investigated by many researchers. The use of audio data for security system is quite common due to easy acquisitions of audio data. Before using the audio data, it is very important to verify the integrity of the audio data in order to ensure the security of the data and prevent its misuse. Before using the audio data in official authorities, it must be proven whether any manipulation has been performed on it. And what is the audio forensic? Audio forensic is the science that provides the acquisitions, development, analysis, and interpretation of audio data. The most important process of audio forensic science is to determine the accuracy and integrity of the evidence. For an audio recording to be used in the forensic units, the audio data must be proven to be non-destructive by experts in their fields. When forensic data in recent years are examined, there has been significant increase in the number of digital audio used as evidence. Importance of audio forensic. While examining forensic data in forensic science, system-related or human-induced errors may occur. System-based errors can be caused by software, hardware, or incorrect information. And human-based mistakes may occur as a result of not detection manually examined records in visual form or a misinterpretation of records. And the existence of system that reliable detects forensic data is very important for the detection of these mistakes. What is the audio tampering? Actually, audio tampering methods are basically divided into two techniques as active and passive techniques. Active techniques access special information on audio data, for example, watermark, hash, and digital signature. However, these techniques are disadvantaged in terms of applicability as they require additional information and the data found in their life don't contain this information. Passive techniques don't have additional information in the audio data. These techniques focus on just analyzing the signal. Since these forgery methods don't contain any informational bilgi, so it is a very difficult problem. Most difficult problems of audio forgery in the literature. audio copy move forgery. We study this presentation. We work audio copy move forgery detection. Audio copy move forgery is one of passive techniques performing by copying some parts of the audio recording and moving them to different location in the same audio recording. In addition, since the region copied from the audio record is divided from the same audio record, this forgery is so difficult because we have one forgery digital records. And let me move on to the next slide, which is included students. Many studies have been carried out in the literature to detect different audio copy move forgery. For example, Lee et al. Proposed Fitch characteristic, their work, and the performance of copy move forgery records without attacks about 93% recalls. And Yan et al. Used pitch and format frequency characteristic of the audio signal, and they compute precision value about 99% and recall values about 100%. But after adding attack 20 dB of Gaussian noise to the data, they calculate the precision value about 96. And another study, Hang et al. Detect copy move forgery in audio signal based on discrete Fourier transform. Next study, X et al. They used various feature extraction method, for example, gammametry features, MFCC features, and discrete Fourier transform coefficients, and detected and copy move forgery on audio signal. They used classification algorithm. They used C4.5 decision tree algorithm. And another work, Imran et al. Developed 1D local binary pattern algorithm to detect copy move forgery. They find accuracy rate about 96%. Another works, Wong et al. They used discrete cosine transform, and their study performance about true positive rate about 96%. Liu et al. Used discrete cosine transform and MFCC coefficient, their study. They calculate recall value about 98%. And after adding noise recording, they computed precision value about 100% and recall value is 97%. Another study, Yan et al. Detected copy move forgery using pitch features of the audio. They calculate this system performance true positive rate about 99%. And edit noise the data, and it's calculate true positive rate about 98%. And another study, Akdeniz et al. MFC data MFCC coefficient to detect audio copy move forgery. They calculate average accuracy about 99%. We will talk about our methods. In this study consists in 3 steps. First, the audio signal are detected, and the audio signal divided into segments for voice activity detection, silent and unsilent regions. And second step, we obtain LPC, linear predictive coefficients are obtained from these separated segments. And after the similarity relationship between the coefficient is determined using the Pearson correlation coefficient and determining the threshold value for the decision phase of the system. We have been obtained 5, 10, and 15 LPC coefficient respectively from each sound segment. We have examined the relation between the coefficient of the segments and analyzed relationship using Pearson correlation method. It's decided whether there is a forgery operation in the audio signal considering threshold value. In this study, the performance result of the LPC coefficient amount in detection audio copy move forgery is analyzed, and number of coefficients that give the best result is determined. The flow chart of the study in before slide. And after we have evaluated on timid dataset containing forgery audios created by performing copy move forgery in this dataset. A total of 200 audio recordings varying in length from 4 to 8 seconds were analyzed. We applying copy move forgery process to this audio recordings. 200 forgery data were processed from the original data. It's aimed that detects the trace of audio forgery by applying different audio attacks to this forgery data. Therefore, a total of 5 different attack types is applied in forgery audio recordings. We used 10 dB Gaussian noise attack and 20 dB Gaussian noise and 13 dB Gaussian noise. And after reduce the sampling frequency to 8 kHz and increasing the sampling frequency to 22 kHz. So with these attacks, 200 is original data and 1200 is forgery data. And we use total of 400 audio files in this study. We used linear prediction coefficient. LPC is one of the powerful, efficient, and popular vector feature extraction method frequently used in audio signal. And after we used yet another algorithm for voice activity detection, silent and unsigned ranges have been determined in order to determine the segmentation part in the audio signal. So the YAPT method has been used for segmentation part. And after, in this study, we used Pearson correlation coefficient used to determine the relationship between the features and find the similarity between two audio segments. Correlation is a method finds the similarity relationship between two data. Experimental result. In this study, LPC coefficient is calculated to detect copy move forgery in audio signal, and thus we aimed at the optimum coefficient amount. In order to minimize the trace of audio forgery, 5 different attacks are applied to audio data. Can you see our results? In table B, copy move forgery without any attack on signal is detected calculating the 10 most successful LPC coefficient. The accuracy of the study around 98 about. And after adding 13 dB of Gaussian noise to signal, copy move forgery is detecting using the 10 most successful LPC coefficient. Our accuracy value of the study is about 96%. Adding noise 20 dB Gaussian noise, our signal, we copy mode forgery is detected computing the 5 most successful LPC coefficient. The accuracy value of the study about 92% about. After adding 10 dB Gaussian noise to signal, copy mode forgery is detected using the 5 most successful LPC coefficient. The accuracy value of the study about 85%. After resampling the audio signal to 8 kilohertz, we calculating the 10 most successful LPC coefficient. The accuracy value of the study is about 97%. After resampling the signal to 32 kilohertz, copy mode forgery is detected using the 10 most successful LPC coefficient. We find accuracy value of the study is about 98%. And in the performance result of the study, more than one metric was calculated and the results are given in table 1. The best values are obtained by using 5 and 10 LPC coefficient. Our experimental result, conclusion and discussion. Shortly, I would like to tell you about my study conclusion and discussion. The most important parts emphasized by many researchers about audio forgery detection are that detecting copy mode forgery is challenging problem, and there are very limited studies in this field. For solving this challenging problem, we have proposed a method detection in audio copy mode forgery, computing LPC coefficient and Pearson correlation coefficient with performance result. We have obtained accurate and reliable results by calculating the optimum number of LPC coefficient and tested the reliability of the system on the forgery dataset. Our methods gives much more mass result than many studies. And in this study, we also tried to eliminate the trace of forgery by applying different attack to the audio data and included system performance result under different attack types. The robustness of the proposed forgery detection system has been tested against different attacks on forgery dataset, and it has been determined to strong against attack. And that's all. Thank you for joining my presentation.
Thank you for presentation.
Thank you.
Is there any question? Okay, next presentation.
Thank you.
Thanks again. Next presentation. Dear Rawa Ali.
Yes, Doctor, I'm here.
Okay, you can start.
Okay. I'm Rawa Ali from Altenbash University. I'm master student. Classification of brain tumor using MRI image based on convolution neural network and supervised machine learning algorithm. Brain tumor. Brain tumor is abnormal cells that originate from cranial tissue. There are 3 types of brain tumor: meningioma, glioma, and pituitary tumor. Meningioma is a tumor of membranes that surround the brain and spinal cord. Glioma is a common type of a tumor which originate in the glial cells that surround and support nerve cells in the brain. Pituitary tumor is abnormal growth that develop in pituitary gland. Early brain tumor diagnosis is essential for therapy of the patient and save the life of them. So we use artificial intelligence for efficient and accurate diagnosis. We need artificial intelligence to solve a complex task. Complex tasks require artificial intelligence system. Those deep learning and machine learning essentially represent the cornerstone of the entire artificial intelligence field and subdomain. Artificial intelligence is used for detection and classification of the different diseases in the brain. Dataset, image of a brain tumor, MRI, are applied to the deep learning technique and classified into individual classes. The dataset consists of 6321 MRI image of 3 brain tumor and no tumor. This is 1621 for glioma, 1645 for meningioma, 2000 for pituitary, and 1055 for no tumor. The source of the dataset is open source Kaggle. The MRI image, there are different directions of the MRI image. That is sagittal, axial, and cornal. MRI identify the location, shaping, and sizing of a brain tumor. The MRI image resized into the same dimension for obtaining the optimal performance. This is the sample of an MRI image are taken. This is a glioma, meningioma, pituitary, and no tumor are taken in 3 dimensions, axial, cornal, and sagittal. Deep learning technique were applied to brain tumor MRI image for extracting feature of them. We use 3 types of deep learning models: GoogleNet, NASNet Mobile, ShuffleNet. GoogleNet contains 9 models of inception, pooling layer, and 6 convolution layer, and contains 2 layers of pooling and 2 convolution layer, and fully connected layer. While NASNet Mobile, using different architecture, consists of normal cell and reduction cells. ShuffleNet, an architecture of a CNN with the high efficiency of computation. The extracted features are applied to classifier of machine learning, which are k-nearest neighbor, support vector machine, linear discriminant analysis, for each one of model of deep learning. We resized all dataset to be fit with the pre-trained models. MRI image, we need to resize and apply to GoogleNet, ShuffleNet, and NASNet Mobile, and then apply to classifier, SVM, K, nearest neighbor, and LDA, and then classify to glioma, meningioma, pituitary, and no tumor. We select the last layer of deep learning to deduce the feature to apply the various kinds to machine learning classifier. This is the result we obtained from GoogleNet, NASNet, and ShuffleNet. We obtained the higher accuracy in SVM, and all of them, with the GoogleNet, with the NASNet, with the ShuffleNet, we obtained the higher accuracy in SVM when compared with the other classifier, with the KNN and LDA. This is a comparison with the other published research. In 2022, this is a class number 4, they gave 89.55. So we achieved to 98.40 for accuracy. The results should be divided into 4 criteria: accuracy, sensitivity, prediction, and F1 score, precision and F1 score. Conclusion: the SVM yielded better results than the other classifier. The result obtained were accuracy 98.40%, recall 97%, precision 96.75%, and F1 score 96.75% compared to the other classifier. Deep learning and machine learning play essential role for diagnosis and classification of a brain tumor that eye doctors and radiologists and rapidly detect of a huge amount of MRI image without consuming time. For future work, we plan to develop a convolution neural network that has a new structure with the fewer layers that can reduce the time consuming to classify brain tumor and increase the accuracy further. Thank you for your listening.
Thank you for presentation.
Thank
Is there any
you.
question?
Thank you, Doctor.
You are
One
welcome.
question, please, Professor.
Okay.
Which kernel you are used for classifiers for SVM?
Here. Sorry.
You used SVM, right?
Yes, I use SVM.
Okay. Why you achieve the higher result compared to the others? Okay, thank you.
The result. Sorry.
Okay, next presentation. Dear Elaf El Samkri. They're not online. Dear Najwa.
Are you hearing me?
Yeah, you can start.
Do you see my screen?
Yeah, no problem.
Good morning. My name is Najwa Nabil Hazem El Sheikh. I'm a master's student in Altenbash University, Electrical and Computer Department. The title of the paper is Predicting Likelihood of Patients' Survival After an Accident Using Statistical Regression. Presentation outlines: number 1, introduction; number 2, research problem; number 3, proposed method; number 4, algorithms used; number 5, results; number 6, comparison; number 7, conclusion. Introduction: a goal of care conversation is a communication process that usually takes place in the hospital setting and occurs between a patient or their proxy and their health care providers. The purpose of the GCC, which means goal of care conversation, is to ensure that the care received by the patient is in accordance with his wishes. Accidents do not occur as often as they should in hospitalized patients who are at the end of life in this population vulnerable to overtreatment. An STR, which means short tandem repeat, serves both to ensure the adequacy of intra-hospital care with the patient's preferences and to inform the patient of a poor prognosis if he was not already aware. The lack of this timely discussion diminishes the quality of care and may result in more aggressive care than the patient's desires. The uncertainty of the prognosis as perceived by clinicians and the time required to properly carry out such a discussion are among the factors that limit STRS short tandem repeats. Estimation of the prognosis is obviously necessary in order to prioritize the discussion of the goals of care. Nevertheless, physicians tend to be overly optimistic about patient survival, which can lead to lost opportunities to prepare patients and their loved ones for end-of-life care. research problem, the latest version of the HSD, which means the Human Survival Database, methods protocol introduces a change in the way survival rates are constructed in the database, improving their estimation by using monthly fertility data. However, this method of correcting survival data do not apply to countries for which birth data by month are not available. Proposed method. The algorithm is based on decision tree. The figure illustrates the nodes, branches, and leaves that comprise the core structure of this technique. Thus, the node denotes a test variable, the branch a single test result, and the leaf a collection of tests. No severe injury crash or severe injury crash. Nodes are classed as root or internal, and the criteria for classification are determined by the route traveled by the node from the root to the leaf. There are several advantages and disadvantages to consider while adopting the DT approach, which is explored in depth in the following sections. While this strategy is useful for small data sets, it demands a significant amount of memory and processing time for big data sets. Algorithms used. In this paper discusses the construction of 5 machine learning-based classification models based on 5 widely used supervised learning techniques. Several examples include logistic regression, decision tree, random forest, and naive Bayesian models, all of which are included in our toolkits of statistical approaches. The performance of the models in compared algorithms like this one are predicted on the following concepts. Logistic regression is a kind of algorithm that may be used to forecast the result of an experiment, LR. A result, the accuracy score of the models that were built using the methods of logistic regression and linear regression was 0.76, which is lower than average accuracy score for equivalent techniques in the industry. The RF algorithm came in first place with an accuracy score of 0.941, while the random forest technique placed in second place with a score of 0.844 for its accuracy, because these models have a low F1 score, which is a harmonic mean of accuracy and recall. The performance of these models is likely to be subpar. The RF model came out on top with an F1 score of 0.942, while the random forest model came in second with an F1 score of 0.851. This model outperforms all the other models that were investigated with regard to the assessment measures. The random forest model finished in second place. On the next slide, you can see assessment scores that are comparable to those produced by the logistic regression and linear regression models. The model was fitted to refine data after the refinement of 9 training samples, and to balance data. Following that, the revised data were utilized to refine 9 further training samples. When this is completed, the procedure is repeated until all subgroups have been evaluated. Finally, the precision of each step is averaged to get the final value. Comparison. Comparing the proposed method with other models in terms of error and accuracy. In this table, I make a compare between my proposal methods and others, such as the method CNN, SHP, data meaning. The accuracy of CNN 93.6% and error 0.3, and accuracy SHP method, the accuracy 84.5% and the error 0.55, and data meaning method, the accuracy 91.5% and error 0.42, and the proposed method regression with 4 algorithms, accuracy 94.2% and error of 0.21. Finally, we can see the results in this table. We have obtained better results than previous studies. Conclusion, the purpose of this study is to develop a model employing regression techniques and deep learning to predict the likelihood of survival for patients hospitalized with illnesses typically observed in intensive care units, ICUs. Survival models are a sort of statistical technique that is commonly employed in clinical research. The objective of these models is to identify potential risk variables and forecast the risk of various clinical outcomes, such as the overall survival of patients with a variety of diseases. The results show that our model can outperform the CPH prediction model when it comes to predicting the prognosis of CCU patients. Thank you.
Thank you for presentation. Is there any question? Thanks again. Next presentation. Here, Elaf. Elaf El Samkri.
Yes, Dr. Hamdi.
Yeah, you can start.
Yes. Okay. My name is Elaf Haidar Sadiq Estamkari, and I am a student in Altenbach University in master degree. This presentation is about transmission line losing determination of electric by using convolutional network. This presentation is contained. Introduction, method, difficulties, result, and suggestion. Introduction to research. Electric power grids are one of the most important and complex scientific systems in modern life. The legacy energy system is being replaced with the transition to power grids thanks to breakthroughs, monitoring, transmission management, and sensors. The phrase smart grids refers to the expression of renewable distributed energy source in order to achieve flexibility, economy, transmission management, and sensor. The phrase smart grids refers to distribution renewable, as a consequence, the focus of this thesis developing effective approach to detect power thieves in order to solve all of the aforementioned difficulties. The CNN elements particular can capture the periodicity of power use data to help identity of power thieves, the model of compounds, the strength of CNN compounds with the BM algorithm. The aim of research develop the power thief detection system based on deep learning smart grids with the goal of reusing electricity generation thieves. Alarm's use contain research to determine optimum, extremely important design for detective power thief in order to select the optimal CNN design. Use